Hello everyone, welcome back to my review and my solutions of the 2024 VCAA VCE Northern Hemisphere Timetable Mathematical Methods Examination 2. So this is the beginning of section B, basically your extended response questions. Okay, so question 1. Oh, by the way, for my solutions and review of multiple choice questions, please see another video on my channel. Okay, so here we go. We have our function f. It's a cubic, x cubed minus px. P is a unknown. It is a real number. And here's part of the graph where p is equal to 3. First question says find the values of the x-intercept of f when p is equal to 3. This is a CAS calculator exam, so it's open book. So we will just do this on your CAS calculator. You solve, first you define the function. Actually, let me do it. So we would do this, and then x cubed minus p times x. So notice I have also defined p to be an input. P is also an input into the function, so that I have control over it. I can change p as I go in the calculator. And then to find the x-intercept, we need to do 0 equals, because the y value is 0 for x-intercept. And then p is 3, so we do this. And those are the answers. The wording of the question is a bit ambiguous. Well, not ambiguous, I guess it's just wrong. Because x-intercept is a point. A point is, and we're talking about 2D plane here. There's an x-axis and y-axis, so this is a 2D space. It's a plane, not a one-dimensional space. It's a two-dimensional space. So when the question says x-intercept, it is a point, and a point can only be specified by coordinates, plural, 2 of them. Any point on a two-dimensional plane can only be specified using 2 numbers in brackets, in order as well. It's called an ordered pair. So here, the language is not exactly correct. There is no value of x-intercept. There is only coordinates, plural, of an x-intercept. So I'm not sure if the question is asking for just the number -√3, just the number 0, and just the number √3. I guess if that's the intention, it's fine. Maybe they're trying to make the student's life easier, because it is the first question of section B. So maybe they want to give more chances to students to earn the mark. But I think pedantically, the language here is not correct. There is no such thing as value of x-intercept. There is only coordinates of x-intercept. And hopefully, if I wrote down the actual coordinates of x-intercept, this would still earn me the mark, the 1 mark, if I didn't just write 3 numbers. All right, next question. Use the derivative f dash to find the coordinates of the turning point of f when p is 3. Since it's worth 2 marks, and the question says use the derivative explicitly, I am doing this by hand just to earn all the working out marks. And so differentiating this doesn't really have any working out to do. You do the little shortcut where you take the power down and you -1 on the power. Make it equal to 0, solve for it, you get x equals -1 or x equals to 1, 2 answers, and then you put them in to your function here. So 3, -1. I think I wrote the wrong thing. Use the yeah, that's not correct. F3, yep, and then F31 is what I'm looking for. -1, 2, and then the other one is 1, -2, 1, -2. To find the, yeah, I must have substituted -1 and 1 back into f dash, whereas I needed to substitute them into f. Yeah. Actually, let me actually do this. So do this again. Basically, this is going to be the derivative, and I'm going to define this, store this into a function, and then turning point, I want those things when p, because the question says p is equal to 3, so I'm going to do p equals to 3. But when I define the derivative, I want this to be the general case because the question is a general case. So when I define it to be a general derivative with p unknown, and then when I actually solve for the question, it says p equals to 3. So that's what I'm going to put in, and then the answer is -1 and 1, and then the following stuff, which I did incorrectly in my first attempt. -1, 2, 1, -2. Yeah. Also, this brings really to my disclaimer. I did not really check my work after the first attempt. So if you do find any more mistakes, please leave them in the comment section. Okay, and then we are looking for the values of p for which f would have exactly one stationary point. So this is where we differentiate f with p being unknown, and then we solve for the stationary point when we don't know what p is. We should get this answer. So this is what I did. Px. This means we don't know what p is. No, sorry. That's let me type this. That. So I'm solving the derivative to be 0. And then those are the answers for the x value of the stationary point, which I wrote down on paper. And I have two answers for stationary point, which means I have two stationary points, but there is one scenario where these two values are indeed the same, the one and the same, and that's when p is 0. Because if you have square root of 0, square root of 0, then it's 0. There's no positive and negative 0. Okay, and then find the values of p for which f would not have any stationary point. This is when the answers for stationary points break down. The answers for stationary points stop making sense, right? So what p-value will make the answers for stationary points senseless? And it is when you cannot take the square root, and it is when p is negative. So if p is negative, then you can't take the square root. Okay, so f passes through the origin for all values of p. Use calculus to show the tangent line to f at the origin has equation y equals to -px. So these are 2 marks, and then it says use calculus, so I'm doing this by hand. So the tangent line at the origin, so you div f, and then you sub x equals to 0 because that's what origin means. The gradient is -p, so the tangent line is y equals to -px plus c. And because the graph goes through the origin, the tangent also goes through the origin, so you sub 0, 0 in to find c. C turns out to be 0, of course. And then the tangent is y equals to -px. And in terms of p, the area of the region bounded by the function f, the line y equals to -px, and the line x equals to p, where p is bigger than 0. The first thing you should do is to visualize what exactly is happening here. So I'm going to define the tangent line also, so -p times x. And first we need to understand what's going on. So when the question says, where's the question? Question says the area, we need to be able to visualize and see the area before we know what to calculate, because there's positive, negative area, and then which graph is on top of what graph and so on. So all those considerations need to be done. So we're just going to pick a random p-value because that's p bigger than 0. So let's pick p equals to 3, and then the tangent line also. And here we have it. So region bounded by the function f, the line, and the line x equals to 3. All right. So x equals to 3 is somewhere 1, 2, 3 here. X equals to 3 is somewhere here. If you look at my cursor, I'm going vertically up and down. So the area bounded by them is just from 0 to 3, and then the function f minus the tangent, because you can, if you know your cubic enough, you know that 0, 0 is a stationary, sorry, a point 0, 0 is a point of inflection. So the gradient going to the right, if you go to the right, the gradient of f is going to increase. So the blue curve is always on top, right? So even though you can't really see that here, we could zoom in. You can see that the blue curve is always on top and the red curve is always at the bottom. That's because 0, 0 is a point of inflection for a function f, and the gradient starting from 0, 0, if you go to the right, the gradient is going to increase, and the gradient of red line is constant. So change that back to the bigger picture. Yeah, so in terms of the terminal of the integration, it's 0 to 3, and the blue is on top, the red is at the bottom. So that's what we're going to do. So f minus the tangent, but it's minus minus, so it becomes positive. And then we basically use our calculator, and then we find this answer. The 2 marks, my guess of how this those 2 marks are allocated is that 1 mark is the final answer, p to the power 4 over 4 unit square, and the other 1 mark is the setting up the integral. Okay, now the expression for the area found in D2, the previous question, also gives the area bounded by a cubic function kx cubed, the x-axis, and the line x equals to p, where p is bigger than 0, find out possible values of k. So it is kind of strange that the question didn't say k is an element of R, because that's all whatever requirement they want to have on k. Usually when people write questions like this, they need to say what k is an element of, like what set of numbers k is allowed to be in. But so I'm assuming k is any real number, and then it just means that here's the graph. Well, assuming k is positive, because positive number is the easier thing to deal with. I've drawn the graph here, kx cubed. I need the area between this curve, the x-axis, and the line x equals to p. P is positive for sure, so that's good. Final possibility for k. So to find the area that the question is describing, the terminal of the integral is 0 to p, and then it is just kx cubed. And then it says the expression found in the in D2 is the area we're looking for. So it's p4 over 4. So based on the case, k is equal to 1. But then, of course, I said in the beginning, I'm assuming that k is positive. It doesn't have to be, right? So if k is negative, that's why this is why I wish the question can be more precise with what they mean. If k is negative, then the graph looks something like this, and then the situation is p is over here, and if k is -1, then the reflection will be perfect. It's a complete reflection in the x-axis. and the area is the same. It will just be a negative area. But then the question says find all possible values of k, which is a plural noun here. It's got an s at the end, so this gives us a hint as to what the question is looking for. It's looking for multiple values of k. And it says area, so negative area also counts. The area between the curve, the x-axis, and x equals to p is, in this case, p4/4 if k is -1. If it's a simple reflection in the x-axis. So we need to also include the number -1 in the answer. So k is an element of -1 and 1. So this is a set of numbers over here with those brackets here. Okay, and actually let me write that. So if k is negative, we also need to consider that case. Okay, we have a pendulum here, a mass at the end of a string, a piece of string. The string is 0.5 meters. Point O here is attached to a fixed point. So this is a fixed point. It doesn't move, and the mass is allowed to move. It swings back and forth, left to right, right to left. And the maximum extent that the pendulum swings, it swings to A and then it swings to C. It doesn't go beyond A or C each time passing through point B. And then we have the height h of the mass above horizontal ground. It's given by a trigonometric function. The input is angle, it's theta. There's a domain for theta. And then h is the height. Theta is radian. And it is measured anti-clockwise from the vertical line OB. So that's all set up nicely. The mass which is maximum at A when theta is power 3, and at point C when theta is negative power 3. So that's all explained very well. And then when theta is 0, it's at point B. Okay, we are looking for the maximum and minimum height of the mass in meters above ground. So this is just, actually, before we do this, before you go ahead and say, let me just look at the trigonometric function and find the maximum value and the minimum value of the trigonometric function, you need to pause. We need to pause a little bit because there's a domain here. So because of the domain, we need to be slightly careful about this. We are going to define the function 3/2 minus half cos x, and we are going to graph it. Let's open a new graph. And let me check its radian. It is radian, and the domain we have to put in. The graph looks like this. So the maximum, it doesn't really happen on the maximum of the trigonometric function without domain restriction. There is a domain restriction, so we can't just look at the trigonometry equation and find the maximum, minimum, and so on. It's not the turning point. What I'm saying is it's not the maximum is not the turning point. So we say the maximum is whenever theta is power 3, or it could be negative power 3, which is 5/4 meters. That is just calculation. And then the minimum height is when theta is equal to 0, which is 1 meter. And then we need to find to 2 decimal places the value of theta for which the mass has a height less than 1.1. So here, very similar idea. We need to know what's going on. So draw a graph, and then I can make my graph a little bit clearer like this. So you can see that if I want this to be, what question am I? This one, less than 1.1. I'm looking at the middle portion here, in the middle here. So we have, first of all, what we write down on paper is we want the height function to be less than 1.1 and over this domain. So, but then what we actually type in the calculator is this. We type 1.1 equals to h of x, so for x, and then, no, hang on, negative power 3. Yeah, what we type in the calculator is this. We type the equal sign in because I can show you what happens if you type the inequality. So we want 1.1 to be bigger, so like this. If you do this, it's not going to really give you an answer, right? So it gives you some number times a constant, and then so on and so forth. So it doesn't really give me what I want. So what it just means the equation is a little bit too complicated for the calculator to solve properly. Which means if we do the equality, we find the we find the intersection between the line y equals to 1.1 and the curve. From that intersection, I have the two x values, and then I need x to be in between. Sorry, theta to be in between because I want the height to be less than. Okay, so height is less than 1.1. Okay, here is the slight problem though. So it says round to 2 decimal places. So if you look at this answer here, this one right here, if you round that, you will round down, right? Because it's 643, so you round down 0.64, which means, is that what I wrote? Yeah. Yeah. So if you round down, you are at you begin at the actual intersection, and if you round down, you're moving to the right, right? Because it's becoming less negative. When I say round down, I mean it's a bit ambiguous. I mean negative 0.64, right? It's negative 0.640000. So if you round like that, you're becoming less negative. So you're moving towards the right, which means you are really at a height that is less than 1.1. The other option as well, if you round this normally, you would just get 0.640000, which means again you're rounding down. So if you start at the actual intersection, when you round this, you're going to be less positive. So you're going to move to the left here. If you move to the left, then you are really at a height that is less than 1.1. So after you round, you should put a inclusive bracket here, because exactly at theta 0.64, it is a, I don't think my scanner works. There's a little marking on every second page. Yep, it's here. Yep, that's not meant to be there. It's the scanner. So this little dot here, this little dot here is not meant to be here. Oh, it's on every page. Yeah, there's a little dot here. Yep, my scanner needs to be cleaned. Sorry about that. This dot is not meant to be here. That's just a dirty surface on my scanner. Okay, so if you round this from 0.6435 to 0.64, typically, hypothetically, you should put inclusive brackets, because exactly at 0.64, you are at a height less than 1.1. That's what the question wants. And also, if you're at negative 0.64 exactly, you are at a height less than 1.1, so you are including this value. But then the question also says the mass has a height h less than 1.1, and then so it doesn't say, the question doesn't say height less than or equal to 1.1. It doesn't say a height less than or equal to 1.1. So on face value, superficially, you would think that the question is asking for a strict inequality without equal sign, without the underline under the equality sign. So I'm not sure. I'm not sure what the question wants. I'm not sure what the writer of the question intended the answer to be. If we follow the question strictly, it says less than 1.1, which means it's not less than or equal to. So the answer should be whatever answer we get. The sign we put next to it is a strict inequality, not a equal to, not inclusive. But then it also asks us to round. So after you round, there is a good case to be made that you can include the points after you round them. So I am not too sure what the marking scheme looks like. Well, how they will decide on the marking scheme. My hope is that somebody will bring this up in the team of assessors. Assessor means people who mark the paper. I hope somebody will bring this up, and then hopefully they might accept both types of brackets. I am not too sure. So my answer here may or may not be correct, even though you've just heard my argument. Okay, so here we now have a different function, which is the angle function. The angle is a function of time, and t is given in seconds, theta is given in radians. So now the subject is theta, and the independent input is now the time. And notice this information belongs to question C. It is inside question C, not outside, and this will come this comment. I will explain this comment in a moment. And show that the mass is initially at point A. So initial, you are supposed to know what the word initial means. The keyword here, I should have highlighted this, initial. That means whenever you see the word initial, the literal word initial means in English, it's initial. In maths, it's t equals to 0. Which means all we're doing is we're substituting 0 into it. And we get power over 3. And then, so when t is 0, the angle is power over 3. And the question defines it that way. So the question says at point A, theta is power over 3. So we're just going to repeat what the question said in the beginning. Point A is defined be the point when theta is power over 3, blah, blah, blah. And then the way I actually did this, I didn't calculate any of this manually. Basically, I just did this. TH means theta. I basically said theta is power over 3 cos 9x over 2, and then that is what I did on my calculator. Okay, and then question D says determine the period of the pendulum. The period is the time in seconds taken for the mass to travel from A to C and back to A. So here is my problem with this question. The question D says the period is time in second, which means we need to focus on this function here, because this is the function that involves time in seconds, not this function here. This function is theta angle and height meter. There is no time in seconds in this function, so that's not the focus. To do question D, we need to use the theta function. And here is my problem with this exam writing. If we need to use the theta function in question D, then the question cannot be written in such a format where the function for theta belongs to question C only, because the way it's written right now, the function theta is inside question C. It implies, and it should imply, that's the correct implication, convention of writing stuff, not just exam paper, but writing books, essays, research paper, anything you want to write, the convention is if you have a question label, and then under the question label, and then you see the indentation here as well, it's indented. So everything here belongs to question C only, including theta function. So this implies theta function will and is only to be used in question C, and it shouldn't be used in other sub questions. Any questions before C and any questions after C. It shouldn't involve theta, at least with the way the exam is formatted. That's what it says. So if in fact question D requires information which is theta function here, this information, which is the theta function, cannot be put inside question C. It should be put outside question C. So on this page, page 15, this sentence should start at the very left of the page. There should be no the indentation should be no gap. This sentence should start at the very left. The angle blah 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 blah. Theta is this, and then give the theta function, and then it should say C dot indent, and then show that the mass is initiated at point A. If information is to be used more than in question C. So I think this is important. VCAA needs to check the formatting before printing and releasing the exam paper. Okay, let's actually do question D. So it says from A to C and back to A, which means theta goes from pi over 3 to negative pi over 3, then to pi over 3. Which means if I draw this graph here, let me do a new graph. That's the domain. That's the domain. If we draw this, this is pi over 3, because that's what it is. When theta is 0, it's pi over 3. So what I want is from pi over 3 to negative pi over 3 back to pi over 3. Yeah, which means all I'm looking at is one period of the function, of the theta function. One period, and the period is 2 pi over the coefficient of t, which is 2 pi times 2 over 9, and then the answer. Don't forget the unit. So one period of the function is what we're looking for. How many times for t element 0, 30 is the mass at point A? So point A again, point A means power theta is pi over 3. And the easy way to do, which is actually what I did, you could do this properly, but I think that the fastest, quickest way to do this is to count how many local maximum you have, because pi over 3, every time it hits pi over 3 it's a point A. So if you count them, you can pause this video now to count. I hope the amount of maximum you count is hopefully 22. And determine the distance in meters that the mass travel as it swings from A to C. So distance that the mass travel from A to C. So here, that's this arc here. It is asking us to calculate the length of this arc over here. And this string, it doesn't change length, which means it is basically a radius of a circle. Right? So the string is a radius, and then we're drawing a circle, but not a full circle, a portion of the circle. So let's do it. The whole circle circumference is 2 pi r, which is much, pi meters, the whole circle. And then we have the portion of the circle, right? So the whole angle, so if you go around, okay, let me draw this. The whole circle, if you go around a full circle, the angle is 2 pi, right? If you go around a full circle, the angle is 2 pi. And here, the angle that we are covering inside a circle is 2 pi over 3, because it's pi over 3 on the right, pi over 3 on the left, so 2 pi over 3 in total. So the amount of angles we are covering is 2 pi over 3. So if we do 2 pi over 3 over 2 pi, which is amount of angle we are traveling divided by the whole angle of the whole circle, which is 2 pi, we get the portion of circle that we have traveled, which is 1/3 of a circle. We have traveled 1/3 of a circle. And so we take the whole circumference of the whole circle times 1/3, and we get the answer, pi over 3. Oh, long question. Let's keep going. Find the height of the mass after 1 second has elapsed. After 1 second has elapsed, we put 1 into theta to find the angle when t is equal to 1. And from that angle, we can substitute h. We can substitute the angle into h because the height function, like the question is asking for the height function is in terms of theta. So to find the height, we need to find theta. To find theta, we need the time. So that's all we're doing. We're doing sub 1 into theta and then sub that angle into h, and we get the answer. And so, and all I did was this. And then it says state the rule of the composite function h theta t, which is a bit annoying to write. It's got multiple fractions inside a fraction. So yeah, just do your best job to use the space on paper. And then you are finding, correct to 2 decimal places, the average height of the mass in meter. You've got the height function. Here is the height function. And then here is the domain. It goes from negative pi over 3 to pi over 3. So the average height is just this. So you integrate the height function with the terminals, and then you divide by the distance between the terminals, which is 2 pi over 3. Put in your calculator and you get the answer. What I and this is just basically you either memorizing the formula for average value of a function, or you understand it, which is you do an area, you find the area under the graph, you pretend it is a rectangle, and you divide by the horizontal length. Then you get the height of the rectangle, and that's the average value. What I'm not sure about is why this question belongs to G, because question G, GI, GII, and GIII, G1, G2, G3, G1 and G2 are to do with the composite function idea. So you need to use composite function in both G1 and G2. Whereas in G3, I do not believe we need to use composite function because it's just not necessary, unless, of course, I'm wrong. But at the moment, I cannot really see apparently how my response is wrong, could be wrong here. So if you want to both relate to composite function, so you will imagine G3 is also something to do with composite function, but I don't believe it is. So this, in my opinion, should be H. So question, it should be a question H, not part of question G. Unless, of course, you have a different opinion, in which case, feel free to leave your opinion in the comment section. Okay, next question. You have 4 people working at a company full-time. They have an office, and many people work from home in this company. So very nice of the boss. The amount of people working in the office is a random variable with such probability distribution. So expected value of the amount of people working in the office. Hopefully, I think this is also in the formula sheet. It's right here. Yeah. So it's the sum of the outcome times the probability of the outcome. So yeah, we just take 1 times 0.3 plus 2 times 0.4 plus 3 times 0.2 plus 4 times 0.1. Use your calculator. It should be 2.1. And then find the probability that all 4 people work in the office, given that at least 2 people are working in the office. So here is a conditional probability setup. The keyword is given. Given means it is conditional probability. And so you follow the formula and so on. And at least 2 just means 1 minus the event where only 1 person works in the office. Okay, so in a fortnight with 10 workdays, so 10 is the amount of trials, find the probability that all 4 people are working in the office. So all 4 people working in the office on any one day, the probability of all 4 people working in the office is 0.1. It's here. Look at my cursor. And we want all 4 people working in the office at least 3 days. So the amount of success is 3 or more. Hopefully by now you see what I'm doing here. I'm doing binomial. And then write your answer correctly for decimal places. It's binomial because it's got a certain amount of trials, and the probability of success on each trial does not really change. I shouldn't say that. I should just say it does not change. And we have a certain amount of success that we are trying to achieve. So to do this, you need to say, and it's 2-mark. 2-mark question. You need to write some working out, which means you need to define a new variable because it's a binomial variable. So let x be the amount of days all 4 people work in the office. Hence, x is a binomial variable. N is the amount of trial. 0.1 is the probability of success in each trial. And then on your calculator, what we are doing is manual probability distribution. And then this one here, binomial CDF. Number of trial is 10. 0.1 is the probability of success. Lower bound is 3. Upper bound is 10. And that's the answer. With rounding, of course, round to 4 decimal places. Okay, now the business is trying to reduce costs. The daily electricity cost in dollar is modeled by a continuous random variable, which is C. It's got this function here. The maximum daily electricity cost in dollar for this business. Well, the daily electricity cost is the number C. It is the letter C. So here, C can be as small as 0, and C can be as large as 10. The answer is 10. It is not F. F is the probability density function. F, the value of the actual value of F doesn't really mean much, at least not in methods. The area of F, the area under F is the probability. The Y value of F doesn't really mean much. And C itself is the electricity cost. So it is 10. It says here, C can be as big as 10. And the mean, if you ever forget how to calculate the mean of a continuous random variable, again, it's in the formula sheet. We are doing continuous right here, and the mean is right here. So you integrate from the whole domain, integrate from the left of the domain to the right of the domain, and then you take the variable times the probability density function. And that's what we did here. We're just gonna do this on the calculator. And also, when you define this on your calculator, we are not doing a hybrid function. All we really care is the part of the hybrid function that has a actual rule, like a proper rule, x minus 10, 2, 5, 0, 0. And then once that's defined, all we're doing is we're looking for from 0 to 10 x times f of x and dx, which is 4. Find the probability of a given day that the electricity cost is within 2 standard deviation of the mean. Well, 2 standard deviation of the mean goes like this. First, you have to find a standard deviation. But to find a standard deviation, we need to find the variance, right? So sigma square is the variance, and we've got the calculator, so it's not that hard. And we've got the formula on the formula sheet. In the formula, the variance formula involves the mean to begin with, which is not that much of a problem for us because we have the mean from the previous question. So that mean is 4. We find the variance first, following the formula here. Do this all on the test. If variance is 4, then standard deviation is 2. Then 2 standard deviation is 4. Then standard deviation of the mean, it just means you start with the mean, which is 4. You minus 4 is 1 terminal. And then you start with the mean, which is 4. And then you plus 2 standard deviation, which is also 4. And you find a probability. And then you get the answer. This question does not say round to such and such decimal place, so we're just going to leave it as exact answer, which is a exact value, which is a fraction. Yeah, let me actually write down what I did here. This may seem confusing because all the numbers are the same. It's 4 and 4 everywhere. So this terminal is the mean minus 2 standard deviation. And this number here is the mean plus 2 standard deviation. And that's what I did here. That's what the question means by within 2 standard deviation of the mean. All right, moving on. And then now the business owner wants to reduce electricity costs by installing LED sensors. She does some research on LED sensor and then have the following information. In a random sample of 200 sensors, 30 will be defective. The sample proportion, we need to state the sample proportion of sensors that were found to be defective. It is just 30 over 200, which is 3 over 20. Simplify your answer, please. And then use this sample proportion to find a 90% confidence interval for the population proportion of defective LED sensor, correct to 3 decimal places. Here we go. So to find confidence interval, it's right here. There's a formula for confidence interval. P hat is the sample proportion, which we calculated. Oh, no. P hat is 3 over 20 is the sample proportion. And N is the sample size, which we have. N is 200. But that is what we don't have. That is what we don't have. That depends on what percentage confidence interval you're trying to find. Depending on how confident you want to be, 90%, 95%, you could even do 96%, it's arbitrary, or 80%, 85%, 83%. Depending on the percentage of confidence you want to have, the Z value is different. So you need to first find the Z value for 90% confidence interval. Well, the question is how to find it. And you should have this in your notes somewhere. Yes, I have it here. The formula in the Cambridge textbook has a different letter. The formula in the Cambridge textbook has K, whereas VCAA formula uses Z, but the idea is the same. So if K here is the number Z in the VCAA formula sheet. So this is supposed to be in your notes. The K value, to find it, you need this. K is really a number that is in the standard normal distribution. Right? That is the standard normal distribution. So K is a value such that in the standard normal distribution, the area between K and negative K is whatever percentage confidence you want. So let's say you want here. Let's say you want 90% confidence interval. It means on the scale, in the formula, it's not letter Z, so I'm going to stick to it. So you have z here, this is 0 here, and negative z here. It's symmetrical. Hopefully, I've done somewhat a good job at symmetry. That's the area. That's the area. That's the probability on the standard normal. This is 0.9. This is 90%. Let me put 90%. This area is 90%. So that's what we want. We want the z value to be 90%. Sorry. We want the z value to give area between z and negative z 90% in the standard normal graph. And that means this area is 5% because the graph is symmetrical. The graph is symmetrical, 90% in the middle, 10% on the total is 10% if you combine either side, if you combine both sides, and then 5% on each side. So to find z in the formula here, you need to do this manual probability distribution, inverse normal, and the area is 0.05 because you need to know how to use the calculator. The calculator inverse normal function, you need to input some left-hand area. So you need to have a value that you're looking for, which is negative z. We're looking for negative z. And you, in your calculator, you have to put in the area to the left of whatever endpoint you're looking for. The endpoint we're looking for is negative z. The area to the left is 5%, which is 0.05. You can't use any other area. You have to use the left-hand side area because that's what the calculator does. The programmer of the calculator had to make a decision about what their algorithm does and what the inputs should be, and they decided that the input should be the left-hand side area. And that's the z value. So here, the z value here in the formula is this number 1.644. Because it's negative in the calculator, but that's what we expect. I'm looking for negative z. Right, so z itself is 1.644. Once I have that, I can type those things into my calculator. So 3/20, I think that's my p hat. Yeah, 3/20. Yeah, 3/20 is my p hat minus this number times the square root of like this. P hat is 3/20 times, I'm just going to write this out, exactly the same as the formula, 3/20, 1 minus 3/20, and the sample size is 200, so we will put 200 in here, and that's the answer. Oh, wait, hang on. No, that's not it. Sorry, I didn't put this in properly. That's what I need to put in. Not a multiply, but a minus. And that's the answer. 0.108, because the question says correctly clear decimal places. And you can do the same with the plus. So here you just need to plus that, and you get the other answer, 192. Okay, and then the question says a new sample of size n is taken, and it is used to calculate a 95% confidence interval. And it turns out that the 95% confidence interval is this much here. And use the value z equals to 1.96, determine the sample size n. Well, first thing is it is a confidence interval, so it is still, we're still using the same formula, but what is p hat, right? If you change the sample size, p hat is likely to change also. So we need to find p hat first. But if you understand what the confidence interval means, it's p hat minus a number and p hat plus the same number, right? Look at this part here, z square root, it's the same number, plus and minus. So it means in the exact middle, here in the exact middle is p hat, right? Between the two ends of the confidence interval, the confidence interval is p hat minus a number and p hat plus that same number. So in the middle of the confidence interval is p hat. So to find p hat, we need to find the middle of the confidence interval, which we can do. We just add the two ends of the confidence interval and divide by 2. That gives us the exact middle of the confidence interval, which is 11 over 80, and that is going to be p hat. So now that we have p hat, we can start calculate. So 0.062 is the left of the confidence interval. And so that's going to be equal to 11 over 80 because that's p hat minus 1.96 because that's what the question gives us. That is 1.96. And I plug all the numbers in. 11 over 80 come in here. 1 minus 11 over 80 over n. N is the number I'm looking for. And then this goes into the calculator. N is this number. Now, this is a decimal number. N can only be integer. So we round this to n equals to 80. Because if I can type this, what do I want to type? So it's going to be annoying to do. 1822359. Okay, so this is what you need to do really. This answer is 79.9245. So you have two choices. N can be either 79 or 80. So N can be 79 or 80. Here is what you need to do. So you need to actually calculate the confidence interval. So it goes like this. So I'm calculating the confidence interval, 11 over 80, 11 over 80 minus 1.96, minus 1.96, 11 over 80, the p hat doesn't change, 1 minus 1 over 80. And so here is what I need to do. Your n value, let's try 80 first. Let's try 80. That's the left of the confidence interval, the left endpoint. And if we round this to 3 decimal places, I should highlight this. If you round this to 3 decimal places, you're going to get 0.062. 0.062 is the correct answer on your test. We can also do a plus to find the right endpoint, 0.213. 0.213. So that's good. That's at least if you round to 3 decimal places, n equals to 80 agrees with the question. But like I said before, you kind of have a choice. And if all you care is that n is an integer, you could say n is 80, but you can also say n is 79. So let's try that. So if n is 79, the left endpoint is going to be 0.062. 0.062, so that works. And then we do the plus option, 0.213. 0.213 after we round. So 0.213 after we round. So really, this question, if we pick the n value to be 79, we can calculate the, is it 95? We can calculate the 95% confidence interval. And if we round the confidence interval to 3 decimal places, it will also work. 0.062, 0.213. What I mean is, if n is 79, all the requirements of the question are satisfied. Okay, so let me actually add it here. N equals to 79 also works. Try to calculate 95% confidence interval with n equals to 79, round to 3 decimal places. Yeah, so hopefully when VCAA decides on the marking scheme, it is they are careful enough to include n equals to 79 as another correct answer, because it can work. Everything that the question is saying, 95% confidence interval, that is 1.96, and then the interval being those two numbers, when you round to 2 decimal places, they're all satisfied. All those requirements are satisfied if n is 79. Okay. I'm gonna stop this video here. There will be another video to go through question 4 onwards. Thank you for watching.